For design, I would say it's a formalized agreement regarding program correctness between the user and the implementation of a component. I've chosen the word component quite loosely here because it's not really very important in this context if we mean a function or a class or a full API or whatever, but it's some user and some implementation of a piece of software. And it's the regarding program correctness that is a important bit. And also, just to be clear, when we're talking about, we have two things coming in C++ that are sort of similar, but not at all, actually. And they're phonetically similar also to confuse. So we have concepts that are about correctness in terms of types, compile time correctness, and then we have contracts which are in terms of the dynamics of the program, the runtime correctness, the semantics, what are you allowed to do when. So contracts are about runtime correctness. I learned about this at university. I think this was in the winter of '92. We had a course in object-oriented software construction. This was in the heydays of object orientation. There wasn't a problem under the sun that couldn't be solved with object orientation. We studied this using the programming language AFO, designed by Bertrand Meyer. I actually don't remember what I thought about object orientation at the time. I really don't. But in this book, chapter 7, systematic approaches to program construction, where you have the notion of assertion, preconditions, postconditions, class invariance. So this was an eye-opener for me. It changed the way I think about how to write programs, that you specify extremely clearly who is allowed to do what when and who must do what when. So in this example, I'm going to use a ring buffer. This data structure has many names. Since I know about a trainer who once used a ring buffer in an example and none of the students had any clue what he was talking about, I decided to do a very, very, very brief introduction to a ring buffer. So a ring buffer is a queue of fixed capacity. In this case, we have a ring buffer of 12 integers. So when we instantiate it, we allocate all the slots for values in place. And then we can push values into it or pop from the back. And you keep pushing more, and it just goes round and round like that. But the capacity is fixed. It can never grow. It can never be, in this case, more than 12 slots in it. So this is what I'm going to use to explain what I mean with contracts. And I'm going to begin with actually doing a more philosophical approach to what do we mean with design by contract. I keep using the word design because I don't really think that this is an API design principle, first and foremost. Given that in my experience, I'm guessing, maybe a show of hands, who is experienced using with contracts? Ha, not a single hand. Okay, yes, one. One hand, yeah, but that means I did the right thing to try to introduce the ID. So the most important thing is the precondition. A precondition is an obligation on the caller to a function that they must fulfill in order for the program to be correct. So if a call is made in violation of the precondition, the program is in error. You have a bug. So we can go through the functions. Yeah, a precondition may apply to parameter values or object state or both, or if you're crazy enough, it can refer to global variables also. Try not to. So, default constructor. Do we have any preconditions on a default constructor? Memory space, yeah, it's You can say that. I guess it depends on the situation. You can say that, but it's a difficult one. I think in most cases we write our programs under the assumption that memory space is there, and if memory space is not, then we either consider it to be or we have some situations at that time, so we usually don't see it as but I would think almost never have preconditions on default constructors. So, sorry. Is there some maximum to n? Presumably there is, and presumably that would be a compile time constraint, not a runtime constraint. So the only real exception I can think of where it actually makes sense to have a precondition on a default constructor is if you have a singleton, then you want to ensure that there isn't already one constructed, but then you don't want a singleton. So you normally don't want a precondition on a default constructor. The size function, then, that tells you how many elements we have in the ring buffer. The object is constructed. That is a good one, and an impossible one. Because if the object isn't constructed, then calling size is completely meaningless. You have undefined behavior. And you cannot reason about undefined behavior. So, no, it doesn't apply. It's off the scope completely. So, again, I would say the functions that just query the current state in one way or another. You rarely have precondition on those. Actually, I cannot remember ever having had a reason to do that. Oh, moved from. Oh, we will come back to that. We will come back to that. Pushback. Pushback is more interesting. Do we have preconditions on pushback? We can choose to say that, yeah, it's an overwrite. We just lose the oldest element. That is a possibility. Or we can say that the push fails. We either just ignore it or throw an exception, maybe. That is a possibility. Or we can actually, since this is a talk about contracts, we can say that it's a contract saying that, no, you're not allowed to do that. It's an obligation on the caller. So that is the choice I made because that is this talk. Requires is Bertrand Meyer's terminology from the Eiffel language. So we require that when you call pushback, size must be less than n. Pop then, pop front. Yeah. So, depends on the type of T. How do you mean? Oh, you think that way. If T is an optional, we could maybe allow it even if it is empty. That is a good one. I haven't. No one has suggested that one yet.
But then it would be a ring buffer of optionals.
Then it would be a ring buffer of optionals. Yes. So I think we will have reason to return to that one. That was a good suggestion. I would say we face the same design choice. We can say that we make it a contractual obligation that it mustn't be empty. Or we could say if this is a message queue in a threaded system, we can say that no, we wait until there is an element. That is possible. Or in this case, we can make it a precondition. Say that no, you need to know that there is data there. Otherwise, the program is broken. Then we also have postconditions. Postconditions are the other side of things, where we, as implementers of the ring buffer, provide a guarantee to the user about what the effect of a call is, providing that the call was made in compliance with the contract. So we can go through these. Again, the postconditions may refer also to return value, to parameters, to state. Postconditions can be a little bit tricky. So, postcondition for the default constructor. Size is 0, yeah, that is, it makes sense. But we could have said that, yeah, we ensure that it's actually full with default constructed T's. I wouldn't think it's a very good contract, but it could be. Size? Less than or equal to M, yeah. Greater than 0. Greater or equal to 0. Yeah, we could say that. I have chosen to not bother in this case because it's really just reporting something. Yes, Jason?
Well, I'm sorry, like you just said, it's just reporting something. It seems like if it's a non-mutable function, a postcondition doesn't sound like that makes sense to me.
Yeah, it's my opinion also that it doesn't really make a lot of sense. Just.
The fact that it's a const member function is already telling you something about.
That is
already
the
part of the contract. Right?
Yes.
It's saying that the state is not going to be changed.
Yes, we're saying that since it is const, we are saying that the state doesn't change, so it's not very important. But also, it wouldn't be harmful to say that the value is between 0 and n inclusively, but it's not very meaningful, in my opinion. So I decided not to. Pushback. Size is definitely greater than 0 after. Yes.
Size increased by 1.
Size increased by 1. That is a better one. Yeah.
The last element in your ring buffer is the one you just entered.
The last value in the ring buffer is the one just entered. Yes, that is good. Absolutely. I wrote it like this. Ensures is, again, it's Bertram Meyer's terminology from IFO. And also he's using the word old to refer to the state before the call was made. So we're ensuring that the size is 1 more than it was. So now we have told something to the user of pushback to the ring buffer, what we're doing. We could also use something with the value t here and say that, like you suggested, that the value pushed.
That seems like an implementation quality kind of check, not really a user point of view, API kind of guarantee. It's more like a teaching thing.
It's okay. So the comment was that this is more like an implementation issue rather than an implementation guarantee. I'm not so sure I agree with you. But yeah,
it's a correctness thing and not a correct usage thing.
Yeah, but very good, very good. Okay, so the comment was that this is a correctness thing of the implementation, not a usage thing, and that is true. But the postconditions are about correctness of implementation, whereas preconditions are of correctness of caller. Victor?
I have a comment on strong exception guarantee because the pushback is not no except. I swear I didn't see the slides. So yeah, okay, go on.
After that, I have a combat question as well.
Okay, so what if an exception is thrown then? Well, what?
Postcondition is, I assume, only after successful execution of the function, right?
Postcondition is only after successful execution of the function. Yeah, exactly that. So an exception is a force majeure clause of the contract. It's okay, so something completely weird happened. We are not bound by the contract. There are other things that we will get to that are important. But in terms of post-conditions, no. We're not bound by the post-condition in the case of an exception. Jason?
So on that postcondition of back equals t, you just put an extra requirement on your type that wasn't there before, that it be equally comparable.
Yeah. Yes, okay, yeah, so just so that everybody heard, Jason's comment was that when I added this new post-condition that back is the same, is equal to t, then I also added a new requirement on the type of t, that it must be equality comparable, and that is true. And that is why I'm saying that contracts are an interface design principle, where you have to think about what are the implications here, and the implications can be about the types too, what's allowed and what's not. Yes.
This stuff, your post-condition, I mean, you've written it there as a comment, so it's not executable code, right? You're simply asserting that back is the same object, so it's an identity equality, not a value equality.
Okay, Jez's comment is that since this is a comment, this is not code. I'm just asserting that it is an identity. It's not necessarily the same as executing the equality comparison function. So we're talking here currently on a philosophical level over what we mean.
When you added the last ensure, so then you also added an extra member function.
Yes.
So it's necessary for your ensures to add extra member functions.
Okay, so just to paraphrase, when I added this last one, that back equals t, I added a new member function back. So by adding contracts, I also added new functionality.
Is that a good thing, or is it not better to express pushback in terms of pop front?
Yeah. If you don't have a function for back, then your contract is irrelevant because it's an implementation detail that you could violate if you want to, and the user wouldn't notice. Right?
Will it be correct?
So why would you make it a contract then?
Will it be correct to use pop front instead of
No, it would not, because how many pop fronts? Then you have to make a size number of pop fronts to get the value. Yeah, you could do that, but I think that way lies madness. Don't go there. But the question about is it a good thing or not to add a new member function to be able to express a contract?
Do you have to use a public interface, or can you use like private?
I'll get back to that. I think it depends. It can be a bad thing if you feel like you need to expose crazy stuff that really shouldn't be exposed. But it can also be a good thing. It can be that we can say that when we felt the need to add the back member function, maybe we discovered that there was something missing that we hadn't thought about.
My question is, if we wouldn't have the back member function, then the contract doesn't really make sense, because I could implement a ring buffer and put it just somewhere randomly in the memory, and then have some kind of array to keep track of which ones are in which order. And that would still be equally valid. It would be stupid implementation, of course, but
Yeah.
I mean, the contract doesn't make sense because the user never sees it.
That's why you have unit tests that tell you more about it.
Yeah. So it's discussion is super good. We'll come back to this in a very, very, very short time. Very short. Pop front. Post conditions on pop front. Size is one smaller. Yeah. Good. Anything else? Well, we can add a new function front instead, because it really shouldn't be back. Pop front, it should be the old value of front. But, so don't fall into the trap of trying to express the entire dynamic functionality of the structure in terms of the contract. That just doesn't make sense. It's not a specification. It's just some sanity rules saying that you must do this and this must happen. It's the same thing as if you sign a contract to buy a house. It will definitely not state in which order the planks are nailed in. I promise. So don't try to do that. You look at some fundamental properties that must be true. And it's a judgment call to see how much you want to. Is it needed to say that we get the old value up front or not, and on pushback? Is it necessary to say that we get that the back is the value we just pushed? It's a judgment call. And now I have something that is really interesting and really difficult. Clause invariants. Clause invariants are something that are always true for a valid instance when looked from outside the public API. So when a function can be called from a user of the ring buffer, then it must be true. And in my opinion, it is super difficult to write good clause invariants. It's amazingly hard. In this case, yeah, what you had, Victor, about strong exception guarantees, here you have that. The clause invariant is not exempt from throwing exceptions. They must hold. But it's super difficult. In this case, the only one I have been able to figure out is actually that guarantee about the size.
Why does that ensure that the size is greater than 0? Should it require that the size is greater than 0?
I'm sorry, could you?
Your function back has a postcondition size greater than 0.
It should be requires.
Slide bug, thank you. Yes, it's a postcondition. It's an ensures. No, sorry. Back is requires. Yes.
Question for part front. There's a condition that return is old front. What if there is no old front?
If there is no old front, then size was not greater than 0, and then you made the call outside the contract, so the postcondition does not apply.
But if I have exactly one object in my ring buffer.
If you have exactly one object in your ring buffer, then you had exactly one element that was front.
Okay.
Yeah.
You're an invariant of size greater than or equal to 0, and I don't want to start a signed unsigned thing, but if your size was unsigned, then it would be impossible for it to be less than 0.
Yes.
Do you have any comment on that, or you say, no, let's keep moving?
I say let's keep moving. Yeah. It's a good observation that the types of choose do matter for the contracts I write. So if the size type had been an unsigned type, then it would obviously never ever be negative. And if that is a good or a bad thing, that depends on your religion, I guess.
How do you decide if this is an invariant or a postconditional size, since it only costs this one?
Yeah, how do I decide if I want this to be an invariant or a postconditional size? I think it's a postcondition sort of implies that something has happened and nothing has happened in the call to size. The kind of hand-wavy, vague explanation, but are you okay with that as an ID?
Are things like no throw part of a contract?
Or is no throw part of a contract? I would say no, it's part of the type system, I think. I'm not sure. Yeah. I think I'm leaving that one, but it's a good question. What about a moved from object? Suppose that we implemented ring buffer in terms of having a stud vector, and we move a ring buffer. What's the invariant of the moved from ring buffer?
Well, standard vector is valid, but you can still call size or those kind of valid but unspecified.
Valid but unspecified, but then
You can implement your own vector, which
yeah,
doesn't guarantee what
yes, exactly. So I think my take on this, and I'm actually not really sure. This is what my current thinking is that invariance only makes sense for objects that live a long time, that have, you instantiate them, they live, you manipulate them, they communicate with other objects, and then they die. You don't use invariance for value types that you move around, because you get into this weird situation where you either have to over-specify the meaning of a moved from, or you have to make an invariant that is so vague that it's meaningless.
Well, it is true for a valid instance, and you basically make that design decision that it's
Yeah.
either valid or not valid.
Okay, so Adi's comment is that it's my decision because it must be true for a valid instance, and we can argue whether a moved from object is valid or not, because it's sort of both and neither. Valid but unspecified, yeah. And unspecified is really troubling when it comes to contracts, because we want to say, are you in contract or not? So then they're difficult. Contracts and templates, this is a fun one. So if we think about, for example, that turned up here, what if it's a ring buffer of optionals? Should we maybe change the contract then for such a specialization? I would say don't go there, because it's extremely confusing for if you're writing generic code, you're writing template code that uses a ring buffer of T, and this generic code doesn't know what T is. It's extremely confusing if you can get different contracts depending on T. That is not nice. So don't go there. But yeah, we could also say that, yeah, it's a ring buffer of pointers. For pointers, we say that we must not push nulls. But that is nasty. Victor?
Also, a nasty situation you can get yourself into if, for example, T is like future or some type, STD future or some type. It's harder to impose guarantees.
It's hard to impose guarantees if T is a stud future, or yeah, absolutely. So I would say don't try to rephrase the contract for specializations. It's not good.
But again, you have the equal comparison of the T.
Yes, I do have the equal comparison. So, but this is not a matter of a specialization. This is a generic thing. I say, were this executable code, which it currently isn't, it's just a comment right now, but were this executable code, I would say that it's a requirement of the type T, that it must be equality comparable.
But you could also instead just say, if T is equal comparable, then this should be ensured.
Yes, I could say that if T is equality comparable, then this postcondition holds. Yeah, and that, I guess, would be acceptable. I guess that would be acceptable, because you're not adding something new.
It's like a conditional no except.
It's like a conditional no except, sort of. Yeah. Contracts and inheritance. This is also really funny. So we have virtual functions, all of these. A subcontractor, that is actually not my term, it's Bertram Meyer's term. Someone that implements the interface is a subcontractor. A subcontractor, it's allowed from a philosophical point of view, it's perfectly okay for them to have more relaxed preconditions, because anyone who is calling them from the interface, they are guaranteed that if they are within the bounds of the contract of the interface, then they are definitely within the bounds of the subcontractor's interface, because it's more relaxed. But don't go the other way around, because that will be bad. And you can also have stricter postconditions, because that is obviously within the terms of the contract. So why bother with this? Why bother? Well, in my opinion, the strong one is that it can make your interfaces clearer for the user. You express semantic meaning, what is allowed when. And it can make debugging a lot easier. So imagine reading a detective novel. Who done it? We have some kind of contract violation. We have our investigator here, and it's elementary. Because if a precondition is violated, we have a bug in the client. If a postcondition is violated, then we have a bug in the implementation. Or if the invariant is violated, we have a bug in the implementation. Or possibly we have a really bad contract. Because, I mean, you could say in a contract that it is a precondition for this call that the next call to random must be 4. This is an amazingly bad contract, but it's a possible contract. So you can have a bad contract also. But these are the only 4 possible outcomes of a contract violation. And that is good, because it narrows down your troubleshooting. I don't know how many times I've been in discussions with colleagues about something where something went wrong. And we can see that the reason it was wrong was because a call was made under circumstances that the function did not take care of. And then the discussion was the bug that the call was made under these circumstances, or was the bug that the function didn't implement it correctly? With contracts, this discussion ends there. That is good. So, that was the philosophy part, and now we're moving on to the science fiction section of this talk. Because a very brief glance in the calendar shows that it isn't actually C++. It isn't the year 2020 yet, and the standard has not been ratified. And in fact, for those of you who follow it, you know that there is a standardization meeting in 2 weeks. And there are, if I don't remember incorrectly, 7 papers that are going to be discussed that touches on contract. So there may be that some of the things I say now will turn out to be untrue in 2 weeks. Just so you know. Here's the standard, the way it looked some day between Christmas and New Year, so now you know how I spend my holidays. Every square is a page. The green ones mention contracts in one way or the other. The bottom few are really just the indexes and grammar and such.
Is that really enough squares?
Yes. All 1,729 of them. That took some time, I promise.
I was going to ask you if you did it with an automated tool set.
The first lines are just table of contents, so they don't really mean anything. These 4 pages describe the contract attributes, the declarations, and the semantics. So it's not a very big thing, actually, in the standard, or the draft standard. 1 page describing the violation of contracts, what should happen, how do we handle these. 1 paragraph that talks about virtual functions. That is not a lot. 1 non-formative sentence about specializations.
Weaker.
Weaker and weaker, yeah. And the rest are so weak that they're not there. So it's not a lot. By the way, I will refer to a few of these papers that will be discussed in 2 weeks, not all of them. Most of them are about very minor, fine details that are, I think, outside of the scope for this presentation. But I will refer to some of them. But I will not go into in depth about them. So here is what the standard says, the draft standard. By the way, if you're not aware of this draft standard URL, it's a really good one. I had a really hard time remembering what it is until I learned that the person who runs this is named Elis. So now I know. EEL.is/C++ draft.
You can also use
wg21.link/draft. Okay, I did not know that. Thanks. I'm going to have links to all the places where I refer to the draft standard in this presentation. But this is the important bit. So contracts are attributes that can specify preconditions, postconditions, and assertions. So you have an attribute expects, that is how you write a precondition with a contract level and a conditional expression. So you write like this. You have a function that takes a unique pointer and it expects, in this case, that P is not null pointer. And we have this optional level that can be default, audit, or axiom. So default is, well, the default if you choose not to write it. And I'll get back to what these mean very soon. So you could say expects axiom, P is not null. And then we have ensures as the postcondition, where we again have a contract level, an optional identifier, and an expression. So you can write it like this, ensures audit R, where R plus 1 equals V. And the reason you have this optional identifier is that if you want to refer to the returned value, you don't have a name for the returned value. So here you introduce a name, say, in this expression, R here is to be interpreted as the returned value. That is what it is.
So it's always the return value? It's always the name of the return value?
You can give it any name you want. You can give it.
It always refers to the return.
It always refers to a return value. Although you have the sentence here below that if you have an ambiguity between a contract level and an identifier, it's resolved in favor of contract level. So if you say ensures audit colon audit plus 1 is, then you have an error because it assumes that audit means the contract level. So don't do that. Yeah. And then we have assert, which is just a general assertion, the same as the assert macro. The only difference actually between this and the assert macro is that, well, to begin with, it's not a macro. So there are two differences. Yes, it's not a macro, and you can optionally give the contract level.
Yeah, these are attributes, and
yes.
Compilers are allowed to ignore attributes. Is that true for contract attributes?
These are attributes, and compilers are allowed to ignore attributes. I don't think compilers are allowed to ignore standardized attributes. I'm not sure.
Why?
Well, I can say something about that because if you some of the attributes like no discard, they are allowed to ignore.
Yeah. Okay.
But also, someone on CVPcast recently pointed out that yes, they're attributes, but they don't actually follow the attribute grammar.
Yes, Arthur Dwyer mentioned that these they don't follow the grammar for attributes, but that is not exactly true because if you look at the grammar for attributes, they say you have attribute rules and these are these, and then you have contract attributes and these follow these rules. So it's not entirely true, but they are different.
They are different. So maybe they fall under the different rules.
Yeah, they follow different rules.
Assert is supposed to be true
Now, assert is something you can write it anywhere you write a statement, and it must be true exactly there, at the place of that statement. So if you have a function and somewhere in a function you want to check a certain intermediary value that is true, then you can have this assert attribute right there and say that at this point of execution this value must be true.
Could you maybe explain what a contract level is?
I will get to that. But the contract level, it's a way of giving, sort of expressing how important this one is for me. So, and this can be because of the cost of checking it. So if you have the default, you have auditor on a higher level, so you can say that I want my more expensive checks in audit only, and I want those only in debug builds, but I actually want to have the defaults in the release builds, as an example. And then you have Axiom. Axiom is actually never checked, but they can be used by they're never checked in the terms that the compiler will not generate code that checks them, but it can use them for optimization, and it can be used by static analysis tools and so on to say that.
And by the user, presumably.
Sorry?
And by the user, presumably.
And by the user, definitely. Definitely. I mean, just because something is stated as an axiom, it doesn't mean that you're free to ignore it, because then you're a stupid person. Okay. So here's how you can use the assert. And now there are no invariants in the language.
So in the ring buffer example, we had some postconditions that refer to the old state.
In my example, I had some postconditions that referred to previous state. I will get to that very soon, very, very soon. So let's go into this one and convert it from comments to C++20. So invariance, well, I just said there are no invariants, so we may just as well leave it as a comment. Postcondition, well, that is a trivial one. We change it to the insurers.
Can you just stick it there?
Yes, I just stick it. Yes, I stick it in there just before the semicolon.
East or west?
Is this an east or west thing? I think it's mandated to be east. Okay. But I get an error. Because this is a declaration that can only refer to what has already been seen lexicographically, and size has not been seen yet.
But that's but classes don't have that problem.
But yes,
We solved that 20 years ago.
yes, yes. I can only agree that this is not good. But
Is it a compiler implementation issue or
I
standard?
I understand it that it is mandated by the standard to be this way, but I'm willing to admit that I may be wrong. What? Okay. Okay, I need to rush on because I obviously miscalculated the time tremendously in here. Okay. So we have to, as it currently stands, we have to make changes here. But the other ones...
No, you have more
You should
than
have until
half an hour.
10:30.
This is a long
Yeah,
session.
that's what I thought too. Isn't it until 10:30?
Yes.
You have 30 minutes left.
Yeah, I saw a 15-minute sign. So I thought, oh, wow, panic. Okay. This one is also pretty trivial. I expect that size is greater than 0. This works now. This one is no big deal.
So I'm still confused about the assert one, because ensures is triggered at the start of your
Yeah.
function and of methods and requires at the end. The other
Yeah.
way around, sorry.
The other way.
Yeah, the other way around. But assert, when is it? Or is assert
At-
just put in the code itself?
The assert is put in the code at some place where you want to assert that something is true.
It's really just the alt assert macro.
Yes, it is a drop-in replacement for the assert macro. Absolutely.
And it has to be with the function declaration.
Uh,
I mean, sorry, not the assert.
no, these attributes must be in the function declaration. Currently, there is one of the papers. Thank you. Ha. It will, no code to enforce the contract will be generated. Oh, yeah, but it can still be used by the optimizer. So it can see that this must hold true. So even if you have an assert axiom, no code is generated for it, but the compiler can know that, can assume that this must be true and use this information for its code generation. Or a static analysis tool can use this to pinpoint that through this obscure call chain, you can actually end up in violation of this axiom. But here we come to the interesting bit that you asked about earlier. Old size. There is no way. We don't have it. Doesn't exist as the language is. Eiffel did have that, the ability to refer to old values, yes. But C++ as currently proposed does not. So this is a little bit of a bummer. We can relax it and say that it must at least be greater than 0. That much we do know, and can leave us a comment saying that, yeah, it's incremented. It's a bit of a bummer. I don't think it's a complete disaster, but it takes away some expressiveness for sure. The back equals t. Okay, we obviously have a requirement on the type that it must be equal comparable if we want to do this. But let's have a look first here. We see that if a function has multiple preconditions, their evaluation, if any, will be performed in order. And if a function has multiple postconditions, their evaluation, if any, will be performed in order. So, okay, so we can at least, it's no problem to have several postconditions. That is good. But then we have this one. If a postcondition ODR uses a parameter in its predicate and the function body makes a direct or indirect modification of the value, the behavior is undefined. This is problematic, shall we say? I can see where this comes from, because if t is, say, a unique pointer, you have no value to compare with. It doesn't exist anymore, so to speak. So I can see where this comes from, but who wants to bet against that there will be questions on Stack Overflow about this?
I think everything points to contracts being used solely for correct usage, and it's not supposed to be about checking your implementation for correctness. And this is why you can't refer to what you showed about the size being the old state, because that refers to implementation. This is also exactly the same thing. You have to make sure your implementation is correct with other means. Like unit testing.
Yeah, okay, good thing. Contracts, I partially disagree with you, but only partially. Contracts are a way, but a very sort of weak way of enforcing correctness. But it is a very weak way. It does absolutely not replace the need for tests, for unit tests that really exercise the functionality to ensure that it does behave the way it should. So, but I don't think it's wrong to have such postconditions like that. But I find it very problematic that something that I have in a function declaration, that its validity depends on how the function is implemented. that is. I can see where it comes from, but that is not nice. I think that is really unpleasant. So yeah, we can do this, but this is potentially dangerous, and in this case, it specifically won't work if T is say a move-only type like unique pointer. It absolutely won't work. So this is problematic.
You can call it axiom.
I can call it axiom, yeah, but then I don't have any checks. But sure, I can do that. Yeah.
How much do we consider the cost of one of these potential cost of one of these checks? Like equality comparable could be expensive.
Yes.
Would you take that into consideration?
Would I take that the cost of the check into consideration? That is what we have these levels for. I can say that if this is expensive, I choose the audit level or even the axiom level if it's super expensive. So there is where it comes in. Pop front requires size. That is a no-brainer, and this is a problem we have already seen, and this is also a problem we have already seen. We cannot express this. So we get some functionality, but we also get some problems, and we're missing some things. So, violations of contracts, virtual functions, sorry. It doesn't really say much, the standard, about them. But if overriding a function specifies, if an overriding function specifies contract conditions, it shall specify the same list of contracts. So when I said that from a more philosophical standpoint, it's okay for a subcontractor to have more relaxed preconditions and more strict postconditions, that is true from a philosophical point of view. It's definitely not true from a C++ point of view, as is currently proposed. So if you're not specifying it again in a subcontractor, it will use the contract from the interface it inherits from. And I think my suggestion is that whenever you use an override, you don't specify any contract because you're bound by the contract from the interface anyway.
I don't understand this. If you specify it, you have to use the same list, and if you don't specify it, you automatically get the same list.
Yes.
Why should you have?
But you can add more.
Exactly.
You can add more.
No, you have to.
I cannot add more. That is the point. So it's silly. So I either copy and paste or I leave it unmentioned, and I think I prefer to leave it unmentioned because otherwise I'm just taking a risk of introducing trouble.
Wait, you have to specify the same list.
Yes, I have to specify.
Add more?
I have to specify the same list. I'm not allowed to add more. So C++ is as currently specified, a bit over-constrained in terms of what you're allowed to do.
This sounds like a bad idea to implement contracts like this, to be honest.
Maybe we will have reason to come back to that.
It's also, the committee tends to be more conservative with the ability to add those features later.
Yeah. So we'll see what happens. Function pointers. This is interesting. There was it you, Gareth, I talked to yesterday about function pointers? I don't remember. There was someone I talked about function pointers and contracts. This is interesting. The standard says this: a function pointer cannot include contract conditions.
Okay.
So the first example there is a compilation error. This is interesting. And then also, if we continue, you can see that we have a function G here that does have contracts, and we have a function pointer, and it's perfectly okay for it to point to this function that does have contracts. And if we call the function through through the function pointer, the contracts are checked. This tiny little example here says so much about how contracts are meant to work in C++20. So first, a problem. Since we cannot have contracts on function pointers, it means that it's impossible if you have some need for callbacks, whatever. You cannot impose contractual obligations on the callback, which is a bit of a bother. Victor?
I know you're pressed for time, but I'm just curious, have you investigated what happens in terms of function wrappers like that do type erasure, like standard function or function ref kind of things?
Have I investigated what happens with stud function, for example, or function ref or similar? Since you cannot express a contract in a function signature, it's not part of the function signature, so it's gone. You can still call the function, and the contract will be checked, but you cannot express it in the type of the stud function.
So it's still checked?
It is still checked, yes. Yes, it's tied to the implementation. That is what you get. You can infer that from this example, since here it says the last line of the example, int x equals pf of 5. So we're calling g through the function pointer pf, and it is checked. It is checked. So from this we can infer that the checking of a contract of a function are implemented inside the generated function body. There must be. Otherwise, there would be no other way to make this happen. So, yeah, that is how those are supposed to work. We'll get back to some consequences of that.
Can you put contracts on lambdas?
Can I put contracts on lambdas? I don't know. I would think so, but I don't know.
Too many square brackets.
Too many square brackets, yeah. That is a point.
There's other issues with attributes on lambdas, though.
Okay, let's have a little look at how things work. There is a highly unofficial Clang fork available if you want to toy with it, and they run their own compiler explorer. It's not on Matt Godbold's site, unfortunately, or maybe fortunately, because it's actually quite flaky. So we can have a look here. So you can recognize this ring buffer here with the contracts. And I have a very naive implementation that is not really the point in any way. But then I have a function that violates the contract. So what we can see here is that the function f, it calls the constructor and it calls back and it does nothing. So the checks are not made at the call site. But if we look then at the default constructor, we see that it is calling size, checking that it is 0. If it's not, it's calling to terminate.
How do you determine the violation that's in the compiler?
I don't understand the question.
How do you set the contract violation handler?
We'll get back to how to set the contract violation handler. The default handler, as you can see, is just called terminate, which is, I guess that is the last example from the Merriam-Webster's description of what a contract is. And we can also see if we raise the optimization level a little bit, that the compiler does a much better job.
Pretty much describes it.
But we can also toy with some other things, like for example, we can say that I can say that on the I say that the postcondition here on the constructor is audit. No. And then we can see that nothing happens because by default I'm compiling with just the default handler and not the audit levels. So you can choose which levels to compile with, and I'm coming back to that in just a few seconds. But so now you have seen a little bit of how code is generated. Yes?
Without optimization, it will also be optimized away?
Yes. Okay. The question was without optimization, it will still be gone. Yes, because this is orthogonal, completely orthogonal to optimization levels. The only reason that we saw that with a 03 it just became a call to terminate was that it did a harder job of trying to see what does this mean, and it ended up with just a call to terminate and nothing else. So I can go to 0 if you want to. It will actually not make any difference at all. So you can see the ring buffer here. It generates a bit more code, but it still doesn't do the check. All right. There is this paper that will be discussed in 2 weeks. 132 or 20R1, allowing contract predicates on non-first declarations. This by Ville Voutilainen. When I've read the title for it, I thought that was about allowing specification out of order, out of lexical order, but it's not. It's by allowing you to express the contracts completely outside, out of context of the declaration. I'm personally not sure that this is a good idea, actually. It kind of defeats the purpose, but it depends on your point of view. My point of view is that this is an API design principle that really helps you write clear interfaces. And then hiding away your contract is sort of evil. But if you, on the other hand, see this purely as an optimization aid, and you may want to do these on private member functions, then it perhaps makes sense, Arne.
But this could enable you to have the size after the constructor, because you can first declare the constructor in class, and then again just declare it outside of class and put the contract in.
Arne's observation is that this may actually enable me to do the checks for size in an order that makes better sense in the declaration, because I can move the contract to the implementation instead. That is.
Implementation just after the class. You can redeclare the function.
I can redeclare the function after the class. All right. I have not thought about that. It sounds plausible.
And it puts it next to the implementation where the function pointer example showed it really lies at after the compilation.
And what happens if two different declarations have different contracts?
If different declarations have different contexts, I would assume that it is an invalid program, no diagnostic required. That is my guess. Patricia.
I think it kind of makes sense for preconditions to be in the interface because they're for the client, and then postconditions to be with the implementation because that's a testimony implementation. But I was wondering, can you split them? And if you can split them, what is the lexicographical order now? If you have the preconditions in the signature, the postconditions with the implementation.
Okay, you have excellent questions that I don't have answers to. I'm sorry. I'm sorry.
Postcondition can also be for the user, right? If you say this always
Yeah.
returns a positive.
Yes, it's so the postconditions are sort of a mixed beast because they tell you what the implementation promise is, and in part that is a check that the implementation does what it should do, but it's also really good information for the caller. You had a question?
More like a clarification, I think. Last time I read about contracts, there was a paragraph about if there is several declaration or definition of a function with contracts, on some either all of them have the same contract, or some of them don't have anything and will inherit the contract from before.
Okay, that is. In what context? I know that is true for virtual functions, but in a case like this, I'm not sure. I don't know.
Yeah, it was last time I read the paper, but maybe.
Yeah, I think I have to leave that. I don't know. Okay, let's move on. Policing contracts. We have touched upon that a little bit. The standard says this about it. A translation may be performed with one of the following build levels: off, default, or audit. A translation with build level set to off performs no checks, which makes kind of sense. So maybe you want this for your release builds.
Does that also mean they have no impact on optimization?
Does that mean they have no impact on optimization? No, it does certainly not. The contracts are still observed as being contracts, but no code is generated to do runtime checks on them. But the code optimizer is definitely allowed to make use of it, and I would expect compilers to do that.
I'm sorry if I missed this in your earlier examples, but have you actually seen the compilers doing optimization based on this?
I have not seen the compiler do optimizations.
Sound like that's an unknown.
Yeah, it is an unknown. But I have not seen the compiler do the optimizations based on it. But in fairness, I have only tried this with this highly unofficial and very flaky Clang fork, and I also have not spent a lot of time trying to enforce it. Arvid?
You can already get sort of the way of contracts enabled optimizations. I have that in my own assert macros, where certain compiler intrinsics, and I have seen maybe one or two optimizations enabled by those. So far, compilers don't do anything.
So if you try really hard, you might get something.
Yes, if you try really hard, you might get something, but on the common case, I wouldn't expect anything in the near future.
Okay,
Maybe contracts will give compiler writers more incentive to actually enable more optimizations.
Yeah.
So far, it is.
I guess it also depends on how popular they are. Now they use
Yeah.
it.
So for the YouTube audience, Arvid's observation is that using some compiler intrinsics, you can, but you have to work really hard to get optimizations. And whether or not we will actually see this will probably depend on how much compilers will bother, depending on how much pressure they get from users. Because now at least we have a standardized way of expressing contracts, which means that they have something standardized to base their optimization decisions on. Okay. A translation with build level set to default performs checking for default contracts only. A translation with build set to audit performs checks on default and audit. But there is this paper, I will really not go into any details here, but the idea here is that maybe you want to be able to set the build with different checking levels depending on the contract types. The argument is that in terms of catching bugs in the author's experience, and I actually agree, is that the preconditions are the ones that really gets things. The others are less important. So maybe you should have one means of controlling the level for the preconditions and another means of controlling the level for the postconditions. It sounds reasonable, I think. I'm not sure what the implications will be if we go that route, but it sounds reasonable, I think. But as the standard currently stands for at least 2 more weeks, that is not the case. The mechanism for selecting build level is implementation defined. The translation of a program consisting of translation units where the build level is not the same is conditionally supported. I actually had to look this up, conditionally supported. A program construct that is an implementation is not required to support. Each implementation documents all conditionally supported constructs that it does not support. So compilers are meant to support this, but they are allowed not to. But if they don't, they have to document it.
But what does that document? Can they document it by saying it's undefined behavior if you do this thing that we didn't support?
Pause.
Well, I would prefer a compiler, yes. I'm just wondering what that means.
Yeah, the thing is that I think it will probably be an undefined behavior in that case because it's a link time issue. It's not a compile time issue.
Yeah, but it could report it. It doesn't have to be a runtime undefined behavior.
Well, hopefully it's a linker error. Let's go with that.
Yeah, hopefully it will be either way it will just work or it will be a linker error. But I don't know.
Current compilers already have like different ways of supporting differently compiled translation units. So, for example, you have one translation unit with ffast math enabled and one which doesn't have ffast math enabled. You're in a world of pain, and I'm assuming that's going to be the same.
Yeah, I think you're probably right on that. Okay, this is an interesting one. There shall be no programmatic way of setting, modifying, or querying the level of a translation unit. That is interesting.
That was a security issue.
That is actually a security issue. You should not be able to, if you manage to somehow get inside the executable and do something nasty, you shouldn't be able to change the level or even find out what it is. So we can build using this flag build level of default and audit. So let's toy a little bit with that. Like so, and suddenly we have it's the same. The thing that happened is that the check for size in the default constructor came back. If I go back to default, we have no check in here. Or I can of course set it to off, and then it's very small. I can go to 1, so at least not stupid. And then we see that there are no checks. Yeah, the 0 is stupid. 01 is perfectly readable assembly, and the 0 just clutters it. Yeah, so just wanted to show briefly how that works. You cannot set the build level to axiom because that just doesn't make any sense. Thank you. When contracts are violated, we saw that it calls terminate. But there is a possibility to add violation handlers. So you can add your own violation handler, and it's a function that is optionally no except that takes an L value to a stud contract violation. That it's optionally no except is not entirely true, because if it does throw exceptions, you are in a really bad situation if a contract is violated in a no except function. So don't throw. There is a cop out though. If you really want to be able to just leave, and you're allowed to do a long jump if you're crazy.
What if you want your handler to throw an exception? Basically, the handling is throwing an exception.
Yeah, but if I want my handling to throw exception, yeah, you can do that. But please make sure that you're not violating any contracts in no except functions. Because then you are essentially throwing an exception from a no except function. That means terminate. So don't go there.
I don't understand.
The checking for a contract is made inside a function body, which means that if you're in violation of a contract, the contract violation handler is called from inside the function body. If that function body, if that is a body of a function that is no except, and you call a violation handler that throws an exception, then you are effectively throwing an exception from a no except function.
So it's not optional.
Yes, it's optionally no except. So you can do that, but there are consequences. Contract violation is a small class that gives you line number, file name, function name, comment, assertion level. Comment is, at least in this this Clang fork, is the actual text of the contract expression.
It's like a subversive way to get reflection.
A way to get reflection, yeah.
I can see your next step now.
At least know that somebody will write.
I can already feel the horns growing here. This is evil. This is evil. The violation handler is invoked when the predicate of a check contract evaluates to false, called a contract violation. There should be no programmatic way of setting or modifying the violation handler.
What?
Yeah.
How do you set it if you can't do it programmatically?
We'll get to that.
Okay.
This is again a security issue, that you should not be allowed to sort of subvert the system from within a program. If a precondition violated, the source location of the violation is implementation defined. Again, implementations are encouraged but not required to report the caller site. So we can look at that. So we have a flag. Say contract violation handler is this function. So I have here my own function violation handler that I set as a parameter to the compiler, so we can see the code generated to it. And what we see here, how it works, is that it sets the entry for the contract violation class before calling the built-in handler, and the built-in handler calls my handler with that. This is easier to see with a running example. So I have the same thing here. I have my violation handler and this buggy program. So let's set a breakpoint on my violation handler and run this. So now I ended up in this violation handler, and we can see what the values are. We can see what the file name is. I have very good imagination for file names. Which function it is. It's back, which I think is less informative than it could have been. There are many functions called back. And that is on file line number 21. Looking at this buffer, we see line number 21. That's here. That is not at the call site. That That is not super useful. No, I agree with you on that. This is a quality of implementation thing. It's not what the standard requires. But
can you bypass the normal terminate routine? For example, if you supply your own handler, can you avoid terminating the program?
can I avoid terminating the program? We'll get to that too.
Well, that's here is the question.
Just be with me. Just wait a little while. So we can see the callback here. I'm getting to my violation handler from the built-in handler that was called from within the implementation of back. So here we see if my violation handler through and back was a no-throw, we would be in a bad situation. And one day I will learn to type. So we can see how it printed out that it is back at contracted CPB line 21, and the problem was that size greater than 0 was violated. And now we can see that I'm in terminate, and terminate was called from the built-in violation handler. So my violation handler returned, and then to the built-in violation handler, and then the built-in violation handler called terminate. We'll get there. Patience, patience. Like I said, if you're crazy enough, you're allowed to do long jump. But we have actually one more thing. Translation may be performed with one of the following violation continuation modes. It can be set to off or on. Translation with violation continuation mode set to off calls terminate. A translation with violation continuation mode set to on continues. So now it's up to you. You can choose to call terminate from within your handler if you want to, but it's up to you. So here's just an example showing how it's depending on how it's compiled, you may continue or not. And for this Clang fork, it's a flag when you build. There is a paper by Joshua Byrne and John Lakos saying that it may actually be a good idea to distinguish between contracts that are fatal to violate and contracts that are not. We'll see what happens with that.
How do you continue? I mean, if a precondition is violated and you say continue, does it continue with the function, or does it immediately return and not execute the function?
It continues execution as if the check had never been made. So it continues executing the function in a situation where the precondition was violated. So danger, Will Robinson. If you throw an exception, then it's all right, yeah, definitely. I say use with care. Use with care. Because if you know that you're in violation of a contract, you actually know that your program is running outside of its defined bounds. So it's very unclear what it actually means. And with that...
The caller won't know. I mean, at the call side, there's no way to know if you violated the contract or not, unless you throw an exception.
Yeah. And throwing an exception is a terribly bad idea to capture these, because these are programming errors. So the
call side, something went wrong. So.
Yeah. Yes, I know. I'm not disagreeing with you. I'm just stating what the standard proposes. I'm not sure that is a very good idea personally, but this is what the proposal says. I'm done. I just want to very quickly recap. Design by contract is, note the word design here, it's a way to clarify the responsibility between an implementation and the user. And language support is probably, I should say, coming in C++ 20. But it is lacking some things. We don't have invariance. We have no ability to refer to previous state. And we have some interesting gotchas, like this modifying a parameter value means it's undefined behavior if you refer to it in a postcondition. And template specializations, yeah, I forgot to mention that. The thing the standard says about template specialization is that a specialization is a completely new class. You can do whatever you want. We don't care. So you can have completely different contracts for a specialization. I don't think you should use that freedom. Contracts can be used by static analysis tools, and the optimizer will see if they will be. We have configurable build levels. And I should say that this paper exists. 1426 pull the plug on contracts. Nathan Myers argues that maybe we got this idea completely wrong and we should just scrap it and start all over. I personally disagree very much with that. I think that there are problems here, there are issues, but they're not hopelessly wrong, and we can evolve this in future standards. That is my take. And prefer, if you can, to express the semantics in the type system, because it's better to get a compilation error than a contract violation. And play with it on this fork. It's cool. And with that, I am done. Thank you.